Alright, so hi. Just to start things off, this is going to be not too intense. We've got everything running, right? So if we run this now, we've got our program, we've got our triangle, but there's an issue. If I go to minimize, it will not work so well. And similarly, if I run it again, and then let me just change this around. So let's go to the window and, okay, we'll set it so the window can be resized. Now I'll try to resize it, and it errors out. So why is that? Long story short, the swap chain and everything which was created was based on one kind of image size, and when we minimize, well, the size goes down to 0. When we resize, it goes to a different size, and the swap chain will become basically out of date or not valid. So that's what we're going to be doing today, is just setting things up so that we can minimize and resize things, no trouble. And the basic idea is we need to recreate our swap chain. So we'll go down to the swap chain section of our code and we'll make a function . Okay, now what we're going to do here is after the device is cleared, ready to go, we're going to kind of recreate all of the components of the swap chain. Okay, but of course it would be a little crazy to create things when they already exist, so we're going to have another function which will basically destroy all of these objects. So again, cleanup swap chain is going to destroy each of these things as they exist right now, and then we're going to create them, so in effect we're recreating the swap chain. So the way we can go about this is just go down to the cleanup section. We'll make another function. And we can be a little bit lazy, so we can grab the objects from the cleanup function. Okay, so frame buffer, that will have to go. Okay, so one difference here is before in the cleanup we didn't have to free the command buffers because we were destroying the command pool, and the command pool had all the command buffers allocated to it. Those were automatically destroyed. In this case, we do want to free the command buffers because every command buffer is a draw command to an image, and those images are all going. So we do need to call this free command buffers function. Just a reminder, this data function returns a pointer to the first index of the first element of an array. So that's why we use that there. Okay, so then the pipeline, layout, render pass, that can all go. Image views, swap chain. Okay, so we just copy pasted these destroy functions into this section. Now if we check everything else, instance, device, surface, those should all be fine. We can reuse that function to, yeah, hopefully this makes sense. Okay, so we now have the basic mechanism, right? But of course it's not going to work because, well, of a few things. For one thing, let me just demonstrate that it doesn't work. So it still produces an error. The basic reason for that is that Vulkan does not know when to recreate the swap chain. So what we can do is we can go down to the drawing function, and there are two functions here. This one, vk acquire next image. If we look here, it says it returns a vk result, a Vulkan result. So that can be used. And then down below, this vk wait a second, no, vk present. I think, yeah, vkq will work as well as vk present. And as well as doing their job, they also return kind of like an error flag to say whether something has happened to the swap chain. Now in this case, I'm going to do this right at the end because things might get a little funky if we're messing around in the middle up above. Semaphores and fences, they might just get out of sync. So the best way to do this, I would say, is to go down here. So we'll say, okay, so call this, grab the result, and then we want to check. Now, the error flags that we're checking for are okay, there's one, it's the out of date error, and there's another one which is called suboptimal. Because while we're at it, we might as well do a general kind of error check. Okay, so error out of date means the swap chain just needs to be recreated. Suboptimal means the swap chain is working, but it might not be working in the best way. For instance, if it's been scaled weirdly, like if you take a small image and then you stretch the image up, well then it's suboptimal. You probably need to recreate it, for instance. So if we try this now, maybe? Okay. Okay. Cool. So that's cool. I actually wasn't expecting that to work. Let's check the messages. I think it did give us some message. Okay, so it's saying that the height must be greater than 0. I would expect that in a minimization operation, so then my next test will be, okay, if I just resize it, will it still give me an error message? No, that seems fine. Okay, no issues there. But let's continue because we can make this code a little bit more robust, right? It might work on my system, but not other systems. So that's fine, we can leave that for now. We'll go to the choose swap chain extent. So this is called as part of the recreation. And what we're going to do is we're going to basically query the window to get the width, the physical width and height of the window, right? I mean, that makes sense because when we initialized GLFW, we passed in the width and size that we wanted. It would totally make sense to do that. Okay, cool. So basically what we're doing is we're just querying the physical. Okay, so again, it was working before, but we can still run it again and confirm that yes, it's working. Cool. And just a note, we're still getting this error when we minimize it. It says the height must be greater than 0 because when we minimize it, we're setting it to 0 and we're requesting to create a swap chain with a height of 0. So let's handle that. Okay, so this is just a simple kind of conditional block to make sure that we don't go ahead with recreating the swap chain until it has a valid size. So right now, here we have it, we minimize it, no error, we bring it back, it comes back, no error. We can do that sort of stuff. So this is great, it's working. But in some systems, so what we're doing basically, this is fine, but we are relying on Vulkan's internal checks to bring this flag up, specifically when the window gets resized. So what we can do is we can set things up so that we are also explicitly checking for resizes. I think we can probably, it doesn't matter. Okay, so we've got our own custom variable to track whether the window has been resized, and we can go down to the draw frame. We can add that as one of the conditions. So if we have any of those things, or our window has been resized, we can go ahead with this and also reset that. Okay, so then the question is, how do we set this? Well, we are working with glfw, the windowing library, and we can set up a callback. So we'll go to init window, and we will create a function. So it's fair to say, why are we doing all of this funky business here with the reinterpret cast? Well, the fact is glfw is pretty primitive and it doesn't have a mechanism for setting a generic callback from within a function, within a class, so as a class member. So even though this is a class member function, it doesn't know about the class, if that makes sense. Well, how could it? It's static, so it's defined once for the whole. But anyway, okay, so what we do is we call get window user pointer on our window, and by default that returns a void pointer. We can see the void star there. Now a void pointer is just a memory location. So what we do is we call a reinterpret cast on the void pointer. Now how would that work? Well, the short story is we take that memory location and we treat it as if it was a memory location of an instance of app, if that makes sense. The longer answer is the layout for app, which is defined up above, gives an idea for the number of bytes reserved for each of the members and the types, like the member types. So what this does is it takes this memory location, takes the first X bytes and puts it into such and such a variable, takes the next Y bytes and puts it into such and such a variable. Does that make sense? Okay, so there's maybe two things we need to do here to get this set up. First of all, we've created the window and we need to go okay, so so we registered this function window resize as the function to call when this window pointer is resized. Now, if we look here, it says that it's looking for a particular type of function signature. It has to be a static void function. Oh, sorry. No, it doesn't have to be static. That's fine. No, it just has to have the arguments of, it has to be a void function, has to have the arguments of a pointer to the window, int for the width, int for the height, as in the width and height of the new resize thing, dimension. But that's fine. But if we run this at the moment, well then, yeah, we can. Oh no, we can't. Okay, so minimizing counts as a resize as well, because we're minimizing it, resizing it down to 0. Parent was null pointer. And the reason for this, just close that, stop. The reason for this is that this window user pointer has to be set by hand. So we go to glfw. Set window user pointer. We are working on our window and we're going to use this. This, remember, is the default pointer to the class, the instance which is calling it. So again, run this. And there it is, just as before, but we have the satisfaction of knowing that this will work on multiple systems. Just for fun, we can make this really small. And I'm just going to check if the memory changes. It's hard to see, but I think we have freed up some memory by doing that. And then if we make it really big, oh yeah, then we can see we allocate more memory because we're rendering a bigger image. Anyway. Cool, so I hope that was fun. That'll be it for today, a bit of a quickie. And yeah, have fun. Bye.